All right, welcome everyone, and thank you for attending today's webinar, Visualizing Operations Across the Enterprise, How Self-Service Tools Accelerate Real-Time Insight. My name's Tom Trappell, and I'll be your moderator. And today, our featured speakers are from Meridian Energy, Will Haradweni, Engineering Data Analyst, Charles Chen, Data and Systems Manager. From SnowLab, we have Operations Manager Stephen Back, and from Aviva, we have Senior Technical Product Manager for Aviva PiVision, and Brandon Nye, Product Marketing Manager. Today's webinar is going to cover how you can gain visibility into your day-to-day operations. We'll also feature 2 real-life use cases from different areas from other sides of the globe. And then we'll conclude with some solutions from Aviva that can help you achieve this within your enterprise. But before we get started, I'd like to mention a few housekeeping notes. This webinar is being recorded, and we'll be providing the recording and slides after today's live event. You can expect an email with all the content we're presenting today following the conclusion of our webinar. If you have any questions for our speakers today, please feel free to submit them below through the Q&A option on the On24 digital event platform, and we'll answer your questions at the end of the presentation. If we're not able to get to everyone's question today, we will certainly follow up with responses afterward. Finally, I'd like to mention that all the windows on your screen right now are completely customized, so please feel free to adjust the size and positioning to better fit your own personal experience. And with that, I'd like to now hand it over first to Brandon Nye to get started with our presentation today. But gentlemen, thank you all for joining us.
We have a really awesome agenda today, so I'm going to jump right into it. Aviva works with customers throughout the industrial landscape in various industry segments. We have over 20,000 customers that use our software to accelerate their real-time insights. Over the years, customers have shared literally thousands of success stories at our user conferences. Many of those presentations centered around their data visualization needs in their operations. While our guest customers, Meridian Energy and SnowLab, will discuss their specific use cases with us today, keep in mind that the underlying principles at work in their stories are relevant across all industrial settings. Before they speak, I'm going to spend a few minutes sharing some of the data visualization needs our customers have shared with us over the years. When it comes to the management of operations data, there are many elements that we could discuss. Of course, it's important to ensure you can collect data from all the relevant sources, that you can store it, enrich it, contextualize it, and apply analyses to it. These are all things that Aviva's software helps our customers do. But even once you've accomplished all that, there are some needs that a solid data visualization approach goes a long way to fulfilling. Most of our customers operate in critical environments. When, and preferably before, events happen, they need to rapidly respond. But to respond, you need to be able to see what's happening. For many industrial organizations in our world, this remains a major challenge. Some still have no formal monitoring approach. This means that they don't know about critical issues until there's a failure. One of our wastewater utility customers had this issue with their data centers. They only knew about data center issues when equipment failed. They recognized that to truly gain visibility into operations, you need to continuously monitor your assets, processes, and operations. When there's an event, you need to be able to notify the right people. And those people need the information necessary to quickly identify the issue. When you're in the midst of a failure, an outage, or the like, time is of the essence. There's really no time for collecting and sharing, but that's often the most time-consuming task. Our customers don't want to wait until failure, and they don't want to waste their time. One day, after implementing Aviva solutions, the wastewater utility I mentioned was anticipating a hurricane set to strike the area in just 2 days. Meanwhile, temperatures in their data center started to rise. One of the company's data scientists was out at dinner after hours with their family when they received an email notification on their phone. The data scientist clicked the notification and was taken to a data visualization they had built of the temperatures in the center. The display showed that high temperatures surpassing 80 degrees were spreading across the center and becoming critical. The data visualization also included the contact info for the on-call IT and maintenance staff. The data scientists called them, and they were already on the scene as they had received the same notification and had access to the same visualization. In less than 2 hours, the critical issue had been fixed, and the utility avoided a major data center crash 2 days before a hurricane. Getting the right data with the right visualizations in the right hands makes a rapid response possible. That data center story exemplifies another data visualization need we hear often from industrial organizations: collaboration. The operations data is only available to those at the source. And these kind of managers, production engineers, and other collaborators want to know what's happening with an asset. They have some options. They can walk or drive on over to the site, but some of those stakeholders are concerned about multiple sites. So they can make a phone call, or they can rely on Excel spreadsheets. One of our renewable energy customers shared a particularly painful example. They had built a central asset management team, really intelligent people with years and years of experience. Unfortunately, that team couldn't see a single piece of real-time data centrally. During one critical incident, they had to ask one of the sites to print off a trend every 10 seconds and send them screenshots so that they could understand what happened. Not time-consuming, but they introduce all kinds of error risks and are difficult to use. 10 different engineers with customers need a single source of truth. They need to reduce their time spent generating reports and providing manual updates across departments. You need to make it easy to share insights. After implementing Aviva Solutions, one of our customers in the consumer packaged goods space credited their data visualizations with helping the company get more value from their operational data. Displays gave engineers detailed real-time views into operations. Management had KPI dashboards. Executives could identify cost overruns due to energy usage and overflows. Plant-level workers had instant visibility into product levels. After just 3 years, they had more than 400 displays facilitating collaboration throughout the company. To truly realize, operationalize it across the enterprise, industrial organizations also need to make their data visualization self-service. Too often, data users in many organizations have to rely on IT for access to relevant data. Not only does this delay the access, but it overloads IT with requests. Sometimes the data users have to make multiple trips back and forth to the control room. They engage in lengthy discussions just to pinpoint and pull the data they need. I remember one of our pharmaceutical customers sharing a story of having to crouch down with his laptop on his knees and physically plug into a server to get the data he needed. Your data users need easy, real-time data access. When you enable that kind of access, you facilitate staff to make data-driven decisions and generate innovations. If you provide the data in an intuitive and flexible manner with visualization capabilities that can fulfill different users' needs, it happen fast. After implementing Aviva Solutions, one of our food and beverage customers told us that it was so easy and intuitive that even their bakers can easily set up the dashboard for their bakery units. Within a year of implementing the system, that company had realized over 78 innovative use cases. Here you can see some of the outcomes our customers have achieved when addressing these needs with our products. The University of Maryland College Park reduced electrical outage response times from up to 90 minutes to almost instantaneous. Algoma Steel built over 1,500 displays that provide deeper insights shared across their departments. One user at ADM built one display of 550 assets in. You don't have to take my word for any of this. I'm excited to pass the presentation on to Charles and William from Meridian Energy, who are going to tell you all about their data visualization journey.
Hello, everyone. My name is Charles, Data Systems Manager at Meridian Energy. Along with one of my data analysts, Will Haroini, we are going to share with you how we utilize Aviva Pi Suite within our organization with a focus on the visualization tool, Pi Vision. I start the presentation with a quick intro on Meridian and the data team, followed by some of our business challenges. Then we will spend most of our time discussing our data pipeline, along with how Aviva's Pi Vision is utilized within Meridian. We'll conclude the presentation by talking about results and benefits resulted from the implementation of Aviva's Pi Vision product. We are Aotearoa, or New Zealand's largest energy generator. We have over 2,800 megawatts of installed capacity, which contributes to approximately 30% of the entire country's total generation. Our energy is generated through 100% renewable sources, most of which are from the 7 hydro stations and 5 wind sites across the country, with 2 new wind sites on the way, as well as a new solar farm with a grid-scale battery storage system planned. We are also an energy retailer and provide electricity to 363,000 Kiwi customers through our Meridian and the PowerShop brands. So that brings us to Will and I, who are part of Meridian's data team. We sit within the generation unit to help the business make a difference through data-informed insights and help improve business processes. A good example where we can add value is to provide data to assist with Meridian goals, moving from a routine-based maintenance approach to a more data-informed, condition-based approach. So why this is important? There are a few benefits, but the ones that stand out for us are that provide our actual on-site teams and engineers with more information to do their job effectively, and it contributes to improved asset health, which in a big picture contributes to keeping precious megawatts in New Zealand system and to keep the lights on for longer in Kiwi homes, especially during any cold winters. In my previous slide, I talked about our vision of moving from a calendar-based maintenance approach towards a more condition-based maintenance practices. This is heavily reliant on accessing to reliable plant data and information. In the past, Meridian has struggled with visibility into our generating assets. The main channel to monitor the condition of these assets was through routine or calendar-based maintenance that had to occur during outages. Or we had to get the plant data from the SCADA network, a network environment which is very tightly controlled and managed, and only a couple of people have access to. While this worked, but was not the most efficient and effective use of our resources. Also, there's no single source of truth to find the operational data associated with a particular type of asset. So the goal is to establish a data pipeline from our field sensors to screens, so people can easily find the data and analytics thereafter in the context of an asset type in a centralized database. To achieve this, it means that we needed a way to monitor our generating assets, both while they are online as well as offline. This is where Aviva and the Pi ecosystem came in. The Aviva Pi ecosystem was crucial for this, as Aviva's search functionality paired with the asset framework hierarchy view, making all information available in Aviva Pi Vision. Over the past years, Meridian has established infrastructure that employs Aviva's Pi system. Our generating asset communicates real-time data from site to our Pi data archive, where we can use the Pi asset framework to create a virtual asset hierarchy of our operationals, as well as perform analytics, form event frames, and generate notification to provide insights and monitoring capabilities. We contextualize this, format this data using Aviva's Pi Vision coupled with Dimension Software's Asset Intellect, constructing a platform to collect and present information from various data sources. Now I will pass over the talking stick to Will, who's going to expand on some of the ways Aviva's Pi Vision has benefited us and our team members. This will include Pi Screen that gave us a general overview of our current plant performance without the need to troll through raw data, unit and component overviews for people such as engineers who require more in-depth of data, display of data, physical display on site such that the information is available without needing to boot up computer. Lastly, he will demonstrate analytic user cases that has been enabled through Aviva's Pi system. Now I hand over to Will.
Thanks, Charles. Tēnā koutou katoa. Hello all, my name is William Hironi. So to pick up from where Charles left off, I'm just going to show you here an example of a site overview screen built in Pi Vision. We have it embedded in a product called Asset Intellect, where you can see this hierarchy view on the side where we can store Pi Vision screens for each site. This can also be done in Pi Vision itself. This display shows the performance of our wind turbines for the Mill Creek Wind Farm. You can easily see metrics such as site active power, potential power, wind information, and power for each specific turbine. This slide shows how we can drill down to the turbine level, with the option to go further into component level information. This example is of turbine 101, where you can see graphs of active power plotted against potential power, or the active power against the power reference curve, which is a key measure for the performance of a wind turbine. Similarly to the wind turbine display, we've implemented a Pi Vision screen to give an overview of our hydro units. This captures information of several relevant components for those such as our station operators or engineers to get a quick summary of how the unit is performing at a glance. This slide here shows the implementation of Pi Vision screens on premise in our hydro sites. This one here being in our Manapori hydropower station. As you can see, the monitor can be set up to display a station overview Pi Vision screen, giving our workers an easy access location to get the information that they require. Here is a more novel implementation of data visualization. As you can see, we've set up QR codes on some of our assets, this one being the combined bearing asset. These QR codes link to a Pi Vision screen which is accessible via any device with a connection to the internet. This allows for more in-depth and historical information to be accessible from within our hydro stations. A crucial part of Meridian's endeavor towards condition-based monitoring is understanding the fatigue of our generating assets. There are many important operating metrics that we simply have not had the means to capture in the past, and without this data, there is no way to make condition-based maintenance decisions. So on to the analytical use case example. The goal of this use case was to collate several operating metrics that can be used to determine the fatigue of our generating assets and visualize this information on a Pi screen. The key data points we were interested in include the unit starts and the unit stops, as well as the short starts and short stops. These are starts within 10 minutes of a stop and vice versa. Also, tailwater depression operations, station loading, and the time spent within various generation bands, as well as the time we transitioned into some of these bands. So this slide here will just give a quick rundown of our implementation of Aviva's Pi Asset Framework, but I won't dwell on it too much as it's not super relevant for today's webinar. This is an example of our virtual asset hierarchy for our Manapori hydro station within Pi System Explorer, going all the way down to the unit's component level. Here is an example of the attributes related to this use case model. We can store this information within our virtual hierarchy underneath the respective asset, defining configurable parameters, capturing relevant input data from that asset, performing analysis on it, which is shown in another tab, and storing output information in new attributes, which is just down below. This data is then accessible within PyVision and can be used to create new displays. This is a station display consisting of the station loading and the availability state of the corresponding units. The station loading here is a simple formula that calculates the total generation of the station and divides that by the maximum generation we could achieve given the units we have available. This section here is the graph regarding the availability of our units as well as which units are currently running. This next display shows the total time spent in various generation bands over a user-defined period of time. This section here, for example, shows the time that was spent not running, the time spent in tailwater depression, time spent at full speed with minimal load, time spent within the rough running range, and the operating range, and lastly in overload. The rough running range is the area of most interest because it's the range where the unit degrades the fastest, and it isn't manufactured to run within this band. The overload range is also quite interesting because it can cause more degradation as it's forcing the unit to operate above the maximum operating threshold. The screen here shows the cumulative graphs of our fatigue metrics as mentioned earlier, along with the current values. By double-clicking on one of these graphs, such as this one for example, you can get a full screen view of the PyVision screen. This can apply to any PyVision screen. In this view, you can make some adjustments with the toolbar at the top, for example, to define the bounds of the graph or how the points are being plotted. And by clicking this button here, you can open up a little panel below, and this shows the table which gives you a bit of a look of each metric along with more statistical information as seen below. With PyVision, we have created displays to contextualize raw time series data, providing our workers with trends to monitor the performance of our plant and ideally provided an ability to identify faults early. This work has provided us with a way of monitoring our generating assets while they are still running from nearly anywhere with an internet connection, including beneath the station floor. This work also gives us a foundation to build upon in the area of condition monitoring. It has allowed us to track fatigue metrics such as data within separate generation bands, providing a means for more complex analytics. This data can then be used to fuel larger scale business decisions. Awesome. Well, that wraps up our segment. So thank you all very much for your attention, and thanks again to Aviva for having us. We're now going to hand it over to Stephen Beck from Snow Labs. Thanks, Stephen.
Thank you, Will. Good day, everyone. Thank you for coming on to this talk on Snow Lab and how the world leading underground laboratory leads with Aviva Pi Systems. So my name is Stephen Beck. I'm the operations manager at Snow Lab. And for the last decade, I've been working with my team in the Pi suite of software to advance deep underground science. So today's journey will take us deep underground and starts with what is Snow Lab and what's this marvelous academic institution. We'll then proceed into our world-leading clean space and discuss the challenges that Snow Lab faces and how we have used the Aviva solution to address them. And then we're going to peer a little bit into the future, do some stargazing, and see what's next for us here at Snow Lab. But first, our Indigenous history is important, and it's important to recognize that Snow Lab is located on the traditional territory of the Robinson-Hearne Treaty of 1850, shared by the Indigenous people of the surrounding Atagmanosik and Anishinaabeg First Nation as part of the larger Anishinaabeg Nation. We acknowledge those who came before us and honor those who are the caretakers of this land and the waters. So Snow Lab is located in the northern community of Sudbury, Canada. So picture a picturesque scene of lakes, trees, and rocks that have become the backdrop for many famous artists. So this is where 1.8 billion years ago, a roughly 10 to 15 kilometer meteorite decided to impact the Earth and create the Sudbury Basin. So a rich deposit of minerals, including nickel and copper, and where Valley Creek Mine has existed since 1901. So what is Snow Lab? So we're this academic institution where we operate a 53,000 square foot ISO 6 clean space. Over 1,000 academic collaborators from institutions like Stanford, Yale, Oxford, and Queen's University come to Snow Lab to design, build, and operate the next groundbreaking experiments. In 2015, Dr. Art McDonald won the Nobel Prize in Physics for his research done at SNOLAB demonstrating that neutrinos have mass. We have the deepest underground flushing toilets in the world. And we happen to do all of this 2 kilometers on the ground in an active nickel mine. So why 2 kilometers on the ground? So SNOLAB is the deepest, cleanest lab in the world. The programs we host are in the areas of neutrinos, dark matter, biology, and quantum computing. So why do all this 2 kilometers on the ground? Well, these programs are advancing our knowledge of what the universe is made out of, how it all began, and the role neutrinos play in it. As well, SNOLAB has roughly 20% more pressure than on surface, and biologists are studying the impacts of a higher pressure and low radiation environment on biological systems, including us. You say, Stephen, you haven't really answered the question. Why would you do all of this 2 kilometers on the ground in an active nickel mine? So I'll give you an analogy here. So imagine an orchestra. So you have your violinists, you have your flutes, you have your trumpets, and all these instruments are coming together to create a pleasant harmony. Now, imagine trying to listen for a pin drop. You can't. There's so much noise that the pin is lost within the music. This is why we go 2 kilometers on the ground. The orchestra is the millions of particles coming through us every single second on surface. The pin is dark matter. In order to hear the pin, you have to get rid of the noise. And 2 kilometers of rock is a pretty good way to stop the noise, so you can listen for the pin. This is why SNOLAB is 2 kilometers on the ground. So what's the challenge? You think world-leading science facility, you think we've solved all the problems in the world. So the challenge is while international scientists are listening for the pin, the infrastructure to make that happen is generating millions of data points. And like these scientists wanting to eliminate the noise, we want to be able to remove the noise, structure, and present the data in a visible manner. So this is why SNOLAB has worked with Aviva to deploy Pi systems to make this data visible in a manner that allows us to ensure we meet the requirements needed so that SNOLAB could be the location that makes next big discovery. And we are building on that to introduce more AI to allow for predictive analytics so we can become smarter with the finite resources that we have available to us. So before Aviva Pi, at SNOLAB there was a collection of isolated data lakes. These were being collected through several different isolated PLCs, DCSs, and standard operating procedures, SOPs. So categorizing them a little more broadly, there's data being collected by SNOLAB's various critical infrastructure. So like the pictured 3 megawatt generators. These generators provide backup power to the lab and the experiments themselves. So in the middle is the picture of an operator interacting with the DEEP experiment, one of SNOLAB's hosted dark matter experiments. And lastly, it was data collected by a staff manually to ensure the ISO 6 clean room is humming along well. So on the left is a picture of one of our system operators interacting and recording data from our liquid nitrogen plant 2 kilometers on the ground. So the challenge then is how do you take these data lakes and turn them into insights? So before Aviva Pi systems, there wasn't a method to take these dozens of platforms and bring them into a central database. And without a central database, there was no way to structure the data. And without a way to structure the data, there was no method to provide this data to experiments in the facility. This meant that root cause investigations and continuous improvement efforts was a piecemeal mess and was very labor intensive of interacting with all these different data lakes out there. So we saw the success that Aviva Pi systems was having for our partner and host Valet. So the solution was easy, Aviva Pi system. We were able to take all these lakes and bring them into one central database, structure the data, and make the data visible. So picture is a screenshot of a distillation system on the ground. The system I call a pharmaceutical-grade petrochemical system. The system brought 780 tons of mineral oil 2 kilometers on the ground, distilled and stripped, and added to the Snowplus detector to further study neutrinos. So remember, this is a novel distillation system in a clean room, 2 kilometers on the ground. So screens like this provide the necessary visibility by the project to plan logistics, monitor project schedule, and do root cause investigations. Because when you're running a novel distillation system, things will break. So let's explore this a little bit more. So you start with this 12-meter diameter acrylic vessel located 2 kilometers on the ground in rock. You build this underground distillation system, and the Aviva Pi system is really this bridge between this empty vessel 2 kilometers on the ground and this beautiful running detector. Operators and scientists are able to easily build their own displays. And at the end, you get 780 tons of linear alkyl benzene, 7,000 tons of ultra-pure water, and this world-leading neutrino detector. After safety, lab cleanliness is one of the most important aspects of the lab. to study the pin drop, the radiation from even the smallest amount of dirt is enough to introduce too much noise to these world-leading experiments. So SNOLAB has deployed an array of particle counters throughout the entire facility. We have a dedicated team of scientists and cleaners to make lab cleanliness a top priority. Viva Pi system has allowed for alarming attempts to intercept dirt before it reaches these world-leading experiments. So take an example here. We have a beautifully created, easy to make graph on the left side. I took this from last week. And Pi Vision lets you easily clearly see dust and dirt events here. This allows us to deploy this team of cleaners throughout the facility. And in the end, you get these happy scientists. The beauty of this is really easy and really something we can do on a daily basis. And different people are enabled to make these different graphs. And in this example, stop dirt in its tracks so that these scientists can do the world-leading work that they do. Lastly, Viva Pi Vision has given autonomy to experiments. So picture this beautiful Snow Plus detector that we talked about before. So this is the successor to the Nobel Prize winning Snow experiment. Viva Pi has enabled scientists to create their own displays, alarms, and data analysis. This allows the scientists at Oxford to monitor in real time what is happening with their experiments 2 kilometers on the ground. So here's a couple more examples of this. So we have scientists. So here's one of our world-leading scientists who's on the ground working with our system operators using the Viva Pi system to diagnose different problems, different things that they're noticing. Here's a snapshot from my office that I took the other week of me monitoring one of our chiller systems. And then you have this scientist that we're talking about in Oxford, halfway across the world, who's able to make their own displays and interacting with their systems as they need to. It's really easy, really simple to do, and we can monitor and trend and alarm on different things that meet our needs. So big picture here, why is this all important? We're an academic institution. We don't make money. If the experiments aren't running, well, they can't do world-leading science. So take a supernova, for example. A supernova is predicted to occur every few decades, with the last one occurring in 1987. So we're due for another one pretty soon. And a supernova is when a star in the universe explodes. When this occurs, a wave of neutrinos is sent out first by the exploding star ahead of the visible light. So we've gotten smarter over time. So since the last one in 1987, we developed this snooze network. So this is this international network of alarm clocks that are 24/7 monitoring for a burst of neutrinos. When multiple individual alarm clocks sound, the snooze network puts out an alert that prompts the world's telescopes to look into the region of interest and hope that scientists around the world can study this rare event better to better understand the origins of the universe. You do not want to be late to this party. You want to be the first alarm clock to sound. So using the Viva Pi system with the Viva Pi Vision, be able to ensure maximum experiment uptime. Take another example. The Super CDMS experiment coming to SNOLAB is looking to discover dark matter. This elusive particle that we theorize makes up about 95% of all matter in the universe. The experiment uses liquid helium and will operate at a fraction of a degree above absolute zero. Any outages will result in several weeks of lost science data as the experiment cools back down to this crazy absolute zero temperature. So if you had an outage a month, the experiment would struggle to get any meaningful data. These are why these things are important to us, to make sure using Viva Pi Vision, we're able to maximize uptime of the experiment so that we don't miss that supernova. We don't have so little running time that we don't see dark matter, or we don't explore this further. So you might say, well, what's next for us? So at SNOLAB, like a lot of people, predictive analytics is a huge thing, and we're wanting to use our resources more efficiently, detecting issues before they become problems, and improving experiment uptime. So we started exploring this by deploying vibration monitors on all of our large motors on the ground. So these monitors are continuously being analyzed, and the data is being presented in Viva Pi Vision, alerting our maintenance group to motors showing vibration and temperature problems, so allowing us to address issues before they are noticed by any other means. So the Viva Pi system has allowed SNOLAB to eliminate the noise and listen for the pin drop. It allowed us to take the data lakes, structure them, and turn them into insights for our engineers, operators, and scientists. This enables SNOLAB to be the location of choice for deep underground science. Thank you, everyone, for taking the time to listen to SNOLAB.
Thanks, Stephen. Hello, everyone. My name is Amit Datta. I'm the Senior Technical Product Manager for Pi Vision. So you heard Brandon talk about operations data visualization needs and challenges around rapid response, collaboration, and self-service. Meridian Energy and SnowLab stories demonstrate how Aviva Pi Vision provides the tools necessary for you to solve those challenges. Aviva Pi Vision gives data users an easy-to-use, no-code interface for building dashboards with context-rich data without the need for help from IT or other business groups to access the data. Imagine onboarding new members to your team who begin building their own displays within half an hour. With dynamic displays, your dashboard automatically populates with new data when assets come online. You no longer have to manually add these new assets to every single display. Whether your users are working from home or out on the plant floor, real-time operations data will always be available to them on their laptops, tablets, or even their phones. Aviva Pi Vision also lets users share displays they build with other users, so everyone is working from the same set of data. As a self-service tool that requires no coding skills, Aviva Pi Vision serves data consumers across your organization. Engineers, operators, and plant managers no longer have to make IT requests to access data that is critical to immediate problem solving. With the data enrichment and contextualization features of raw data streams, data analysts and IT staff no longer need to confer with operations personnel to find the information they need. Contextualized data makes it easy for you to find the data you need to begin trending and analyzing. And when it comes to critical operations, minutes matter. A self-service solution like Aviva Pi Vision can save you those minutes. You can quickly build your own displays and trends without the help of other business groups. We've had many releases of Aviva Pi Vision in recent years. These releases have brought everything from tag and asset-based calculations in displays to enhanced event analysis, display management capabilities, and display standardization capabilities. On the next slides, I'll share some of the details about the most recent releases, but I just want you all to know that we're currently researching and soon starting development towards a 2024 release, which will include many process monitoring and display management capabilities. Many of our customers have extremely complex trust relationships across their internal and external systems. Traditionally, these relationships can require Windows Active Directory environments that include Kerberos delegation and numerous cross-domain and cross-forest trusts that are managed. As industrial companies increasingly utilize remote work and adopt cloud and hybrid-based IT environments, they're changing the ways that they secure and manage those complex relationships. They're recognizing and enjoying the new possibilities, flexibility, and scalability that modern authentication options provide them for managing their resources and users. They need data management and visualization options that align with their evolving security and architectural approaches. With the most recent Aviva Pi Vision releases, administrators can configure an authentication mode for Aviva Pi Vision using OpenID Connect or Windows. We have extended the modern authentication capabilities to the Pi Vision admin site and utilities, as well as configuration of the app pools. So in other words, users now have the ability to support a Windows authentication environment or a completely Windows authentication free environment. This enables new architectures where Aviva Pi Vision no longer needs to be on the same domain as the rest of your Aviva Pi system. And that also means you do not need to configure Kerberos delegation on your Aviva Pi Vision server. The most recent release also includes a highly requested advanced tag search capabilities. Industrial companies work with thousands of data tags, often more. When managing data at that scale, the data management process can be complex. Naming conventions may lack, tag names may not always match those in the source system. Some tags may have similar names to others or replace stale tags. tags may not be immediately contextualized into your AF hierarchy. These kinds of issues can make it difficult for end users to find and interpret tag names. Despite this complex environment, our customers need to quickly identify individual tags for use in their displays and ad hoc analyses. That's why we have enhanced the ability to narrow tag search results by filtering on tag attributes. Also, now users can view the description alongside the tag name in search results, reducing the steps necessary to identify the right tag. When hovering over a result, users now see the most recent value and timestamp for the tag, streamlining between recently updating tags and similar stale tags. We're really excited to continue investing in Aviva Pi Vision to help our customers solve their operations data visualization needs. Back to you, Tom.
Thank you, Amit. And thank you, Stephen, Will, and Charles, and Brandon for your presentations as well. Okay, folks, at this time, we're going to take questions from the audience. Once again, please feel free to submit your questions through the Q&A option on the On24 digital event platform, and we'll answer your questions as they arrive. And if we're not able to get to everyone's question today, we will follow up with responses afterward. And gentlemen, we had a number of questions come in, so let me just get started here. Stephen, what feedback have you received from all the scientists using screens across?
Thank you, Tom. Yeah, all the scientists, so we have over 1,000 scientists that come to SNOLAB to do the research all around the world, and they really appreciate the autonomy that this data has allowed them to do, the ease of use of the Pi Vision system, so the ability that needs to have very little background information, all that they can easily pull in data, trend the data, do what they need to do. A lot of these experiments too are pulling the data out of the Pi system and having them control things on their PLCs or setting up alarms and alerts. And so really that ability for them to do things by themselves, having that autonomy and not having to go say to me and setting that up for them has been really great. And there's been really great feedback and positive feedback for the Aviva Pi system.
Excellent, thank you. Will, Charles, you mentioned that in your use case that this has provided the foundation for future analytics. What are some other things that you may have planned?
Well, I can give a go. You can add if you have further comments to make. Yes, so we mentioned that's provide the foundation. We mentioned that our vision is to move a Meridian's maintenance strategy from more routine-based to a more condition-based maintenance strategy. So that requires data. So how do we know when we need to maintain a piece of equipment? So that's based on asset health. So we try to establish a asset health scorecard. So come up with some sort of matrix to define that score. So one of the aspects of that, contributing to that aspect is how we operate the plants. For example, fatigue. That contribute largely to that asset health score, along with our maintenance history, for example, and also the alarms, alerts, that occurred against that particular asset that over the time form a comprehensive framework to determine that asset health score. So that's leading to how and when we are going to maintain that piece of equipment. So that's actually the foundational work we are doing to move Meridian towards that condition-based maintenance. So that's basically fatigue that's contributing, it's a foundation work that's contributing to that framework, how we're going to undertake our condition-based maintenance going forward. Will, do you have anything to add in here?
Yeah, no, great question. Just a small thing to add, Meridian's always trying to generate more power to satisfy New Zealand's power demand. A couple of other models we were working on. One is measuring the benefit of pushing our machines into overload to see how much more we can generate versus the maintenance required. That's really good for justifying, upgrading our assets. And another example is making current processes easier, such as how one of our coworkers is monitoring the vibration on our assets to make sure we don't see any forced outages, really. There's just, two more examples, but we've kind of got a long backlog of ambitious use cases.
Excellent. Thank you, gentlemen. Amit, this next question's for you. Does the system provide insight into the residual life of monitored components?
So I think we saw a little bit of that in the SnowLab presentation where they were using predictive analytics. In terms of residual life, a lot of that would be configured on your AF system. So you can build analyses and calculations there. You can integrate with things like Aviva Predictive Analytics to get, and then in PyVision. So we have seen use cases like that accomplished by our customers.
So just to reiterate and kind of follow through on this kind of follows into my next question about could an individual or an enterprise have predictive analytics with PyVision, or is it only descriptive? Can you just emphasize that?
Yeah, we have a separate offering for predictive analytics. So that is an Aviva offering, and we have seen integration with predictive analytics and PyVision. So there are some other customer stories and use cases around that we could follow up and share afterwards.
Excellent, thanks. Amit, our next question, we have one group that their goal is to decrease the order of all the values of a certain variable within a certain period of time for one of their dashboards. Are they able to filter by time periods that meet a certain condition? And they're aiming to create a trend that portraits only those that are at specific intervals, within those in-between areas. And is that possible?
So sounds like they want that would probably be that's doable in PyVision if you're using calculations, so you could filter on certain conditions. Our trends can be configured with specific time intervals. So if you wanted to event, if that's configured in an event frame, you can go into our event details or event comparison space. So it sounds like there's a few different setting the right context to either their display or using event frames to set the context of the time context of the display.
Thank you, Amit. Stephen, Will, Charles, I'm going to go around with this next question with the three of you. How difficult was it to set up your Aviva PyVision displays? Stephen, you want to start?
Yeah, so I mean, for us, it was actually super simple. Like to me, I'm just a mechatronics engineer. I don't have any significant software data analysts behind me. I was able to watch all the webinars that Aviva puts out in terms of learning how to use the database. It was really easy to set up alarming events and all that, and then to go into the PyVision environment. Like it's just, even this morning we had an event the other day. I was able to pull in the relevant data and create a screen there to analyze the data and look at it. So to create displays, like we was talking about earlier, it's literally seconds to create there, and to work within the back end there in the PyAF framework. It's really simple to use templates and make changes there as needed.
I can give a go from reading. How easy? I can tell you the training we provided. We provided 4 hours of training to our users when PyVision was kind of adopted by Meridian. So 4 hours break into 2 sessions, 2 hours each. So after 4 hours, users basically capable of developing their PyVision screen, their own display on PyVision. So that's, I can just quantify, just give you that number, 4 hours, how that's so straightforward. The second one is the beauty with the PyVision or Aviva Pi products can be normalized. So if say mandatory, we have 7 units, we don't need to build a display for 7 units one by one. What we just need to do is we build one. If those units share the same attributes, we just build one, then normalized across the 7 units, then it's very scalable and can be normalized easily. So that's just 2 points for me. Will, do you have anything to add? Because you dealt more directly with the site group.
Yeah. I mean, the question was pretty well answered before me, but from my side, I'm quite used to working with like Python and the matplotlib library, which for all of its benefits has a lot of difficulty in terms of formatting that at least I've run across. But yeah, PyVision was super easy to pick up because it's got several widgets already built in that make formatting and just, resizing and all that real easy, like, a chart or just a value, the gauges, you just click and drag it onto the screen, change the colors, and it's a nice display, really.
Will, I'm going to stick with you and Charles for this next question. One of the things mentioned in the presentation you provided, you mentioned that the search functionality was crucial to achieving the goals for Meridian Energy. Could you and Charles go into more detail on that?
Yeah, I give a go first. Search functionality. So when I say search, probably how easy for people to find the information they're after. So Aviva PyVision really making that process streamlined. People can easily find the information in context of an asset type. That's most important. But over the years, Meridian tried to also establish a kind of a Pi community. So everyone get familiar with a asset structure called KKS. So for example, I can give you an example. So can you tell me the current on-read phase of a transformer at Manipur Unit 01? So how do you find that information? So over the time, people get used to the KK structure within Meridian. So what they do is go Manipur, click on the Unit 01. So what transformer? BAT. So that's the KKS we're using. So we got the transformer, we drill down to the BAT level. The information associated with that transformer is all there. So you can see it's very easy to navigate to the information. That's my understanding of the search capability. Will, do you have anything to add?
Yeah. So with the Pi products, majority of the tools have really good search functionality where you can filter by tag name, description, point source, engineering unit, and all the likes. With our current version of PyVision, we kind of struggle due to our standard tag naming. However, Aviva's kind of listened to, our feedback, and with this new 2023 patch, our engineering team is currently rejoicing because the search functionality looks exactly how we want it. So we're really looking forward to implementing that new patch to get that more in-depth search functionality, which was already kind of mirrored in the other Pi products, which works really well.
I have a couple questions for you next. Is it possible to enter manual?
So manual data entry is not current functionality in PyVision. We do have an open feedback item on our feedback site for that. I can talk a little bit more about that. We do have Aviva offerings for manual data entry. So one of those is Aviva Mobile Operator that allows you to write back to your Pi system. So right now we've positioned PyVision as a data visualization tool and not really intended to write back to your Pi system. So we can follow up with some demonstrations or conversations around that can help you achieve that functionality.
Thank you, Amit. And is it possible to program Aviva Pi Vision? And if possible, what languages are available?
Program. I think that question may be around maybe I'm thinking it might be programmatic display creation, or might have to clarify that one a little bit.
Are there different language packs that you can install into the system, is what I'm asking.
Okay. So yeah, Pi Vision does ship with a language pack kit. So if this is about localization into different regions of the world, then we do ship with nine different languages. Don't have them off the top of my head, but most of the major, I think we have like Portuguese and French and Spanish, if that's the question.
All right, thank you, Amit.
Mm-hmm.
Steve, Will, Charles, I'm going to come back to you. What are the key elements that made Aviva Pi Vision stand out from other solutions? Since I started off with Stephen last time, Will, Charles, would you mind giving us your insight into that?
There are many benefits I can. It's just one of the elements, right? Making Pi Vision standing out. That's the question. Yeah. There's many in the past. Before when I joined Meridian, we're using Pi ProcessBook. So I don't know if everyone familiar with that product. So it's not really easy to share, for example, display. So we have to making a screenshot, everything, then send people by email. So one of the key functionality is making that share function really easy with people. So what we just need to do is just copy a URL that we created for display, send the email, people just clicking to open that display. It's also interactive, self-serve. So that's probably one of the elements or key benefits. Yeah, that's one thing. Well, anything from you?
I don't have too much to add, as I wasn't really around for the choice, but from using it, a lot of the benefits come from the ease of access and how well it fits into kind of our pipeline and workflow. But yeah, a big part is the ease of access. You don't need a whole lot of qualification or training behind you to just pick it up and go and create really usable displays that can contextualize your data for basically anyone to look at.
I was gonna just add, to me, it's scalability relative to some of my colleagues and other presentations I've seen that have massive sites, global, millions and millions of data points. You can scale up to that. You can have a very small site, as well as scalability in terms of features. You can use just Pi Vision, have data points and do that, but you can add a whole bunch of packages, both Aviva offerings and partner solutions into that to really add richness to that data. But out of the box, you can choose how you want to expand it. You want to choose how to use it. So it's that ease and flexibility there that the Aviva Pi system platform really grows with you as an organization, as you as an organization grows as well.
Excellent. Thank you, gentlemen. Okay, folks, we are approaching just going to take one more question from the audience. Questions today. We will certainly follow up with responses afterward. And Amit, I'm going to leave this last question for you. First off, are there places where individuals that are working with broilers or maybe refrigeration systems could acquire templates for Pi Vision? And if so, where would they find those?
So we do have a number of groups like our services and pre-sales teams that have built out in industry demo kits, and so they may have something along those lines. We also have AF example kits that help you build a relevant AF hierarchy that fit specific industry needs. So that would probably be my first step in terms of looking for specific asset type of solutions.
And if current users wanted to learn more about upcoming releases of Pi Vision, where would they find that?
We have a few different places that we keep our both customers and internal folk up to date on our plans and roadmap. The first stop I would recommend is check with your account team, like your customer success manager or your account manager, to schedule a presentation of the Pi system roadmap. We keep those up to date year round. The upcoming plans. We also have a feedback page at feedback.aviva.com. So as we were working on this past release around modern authentication and our advanced tag search, we let customers know of our upcoming plans by changing the status on those feedback and in development and completed. And we're going to start that cycle for the upcoming features that we'll have in the 2024 release over the next few weeks and months as we start development on that.
Excellent. Thank you very much. Okay, folks, that concludes our webinar for today. If we did not get to your question, we will certainly follow up with responses afterward. And if you do have additional questions for us following today's event, please feel free to reach out to us from one of the follow-up emails sent out after the live session. If you're interested in learning more about Pi Vision, I highly recommend you join us for our upcoming live demonstration on February 29th. A registration link to that event is located in the resource list at the bottom of your screen. Once again, thank you all for attending today's event, and Amit, Charles, Will, Stephen, Brandon, thank you all for your presentation.
Thank you.
All right.
Thanks
Take care,
again.
everyone.